By analyzing the UK Biobank, we found that certain clonal hematopoiesis mutations have a positive association with higher BMI, so in BMI over 30, and certain mutations have a negative association with obesity. And JAK2 is one of the mutations that had a negative association with higher BMI values. So, what we think now, so what we saw in our mouse model, that by giving a high-fat diet, mice showed an impaired MPN disease development and a delayed disease development. And we did bulk RNA sequencing and single-cell RNA sequencing, and we searched for factors that are causing these effects. And one factor is, for example, interferon signaling, and that's a major hit due to the fact that we already use interferon to treat individuals with MPN in clinic, but we never tried to use these drugs for patients with clonal hematopoiesis. So, and we are right now doing the same experiment in our mouse model. So we are treating now our mice that have a clonal hematopoiesis with certain cytokines and hormones to see if that impairs disease development, and hopefully that gives us a step to the transition, testing some of these drugs also in clinic. We were very surprised due to the fact that we thought that inflammation in general is more or less promoting most clones of clonal hematopoiesis. And we are still working on the fact if that's also a real finding in humans, right? So because using a high-fat diet in mice is a really strong intervention that usually don't take place in humans, using a 60% fat diet with sugar, so that's a lot that we do not have really in a human context. And also some of the changes in the mice are quite subtle, but nevertheless we working with the hypothesis that this is a true biological finding, and that we can use that as a resource by modeling this in a mouse to find new targets.